Hello Year 7, we're going to continue looking today at how binary is used in storing information in computers, and we looked at this diagram last time out. So we've got the top part where the user saves the file, so we'll know how to do this. We've all done this. You click save and then the magic inside the computer happens, but that's what we're looking at, isn't it? We're looking at what happens inside the computer. So we know that information is going to get stored in binary. So the next step, that middle step here, is the CPU, the central processing unit, carries out the conversion from the data we see on screen into binary. Once it's converted into binary, it needs to be stored, and it gets passed on to the hard drive where all the information can be saved and stored even when the power is off. So last week we had a quick look at this explanation text that I'd like to read again for you now. So as I go through, I'm just going to point out some of the things that I've done as I've written this, because it's going to be useful for you, because you're going to plan your own text like this one today. So you're going to plan your own explanation text just like this one. So first of all, we start with the title, How Computers Save Files in Binary. Now that title does a really good job because it tells the person what this is going to be about. If you're looking for some information about binary and you read that title, you'd know that this might be for you. If you're looking for something completely different, again, you're going to know it's not for you. So the title should really tell the reader what you're going to find out about. The introduction does a bit more of that job. So saving files on a computer is a regular part of everyday life. Saved files on a computer can be stored permanently, even when we turn off the machine. How does this happen? How does the computer memory store this data? What language does the computer use to remember this information? So there I've got a little bit of background in terms of what this is going to be about, storing files on a computer, and I've got 3 rhetorical questions. How does this happen? How does the computer memory store this data? What language does the computer use to remember this information? Now these are rhetorical questions because they're not answered immediately, but what they are doing is they're telling the reader what I'm going to tell them in the rest of the text. So they're going to know, they're going to get the answers to these questions as we go along. So then I've got a subheading. This is the first part of my explanation, and I'm telling them what this paragraph is going to be about. So saving a file. As a file is created on a computer, for example, a Word document or PowerPoint presentation, information is being created. Each letter or image in our document is a new piece of information that will need to be stored when the file is saved. When the file is ready to be saved, the user simply clicks on the save icon or selects Save in the File menu. This starts a process within the computer which ultimately leads to the file being permanently stored in the computer's main memory. Okay, so lots of information there that you might think everybody knows, but if somebody's looking up this information, they might not know it. So we're going to start right at the start, and you'll notice I'm starting in chronological order, so I'm starting at the start of the process. The first thing that happens when we save a file is someone's going to click on the save button. So we start in that order. Moving on to our next paragraph, converting the file. Now here you'll know, because I'm in chronological order, I've got a nice time connected here. I've got when. So when tells me that this is happening in a particular time order. So converting the file. When a file is saved by a computer, it must be stored in binary. This is because the computer's hard drive can only store ones and zeros. As a result, all files are converted before they're permanently stored inside the computer. The central processing unit, CPU in brackets, that's giving them a bit more information. So the central processing unit is sometimes called the CPU, so they'll know that those two are the same thing. Sometimes called the brain of the computer, takes the file being saved and converts it into ones and zeros. Binary code. The computer uses a pre-made set of rules to store different information types as binary. On to our third paragraph. Storing the information in the main memory. Again, I've got a nice time connective there to show that we're moving forward in time, these things happening one after the other. Once the file has been converted by the central processing unit, it's ready to be stored in the computer's main memory, the hard drive. The hard drive can only store information as binary code. The binary of the file is saved on a disk, which stores the information magnetically. The information is written on a disk by a mechanical arm called the read-write arm. The read-write arm holds a powerful magnet that can alter the information stored on the hard drive disk. As the information is stored on the hard drive disk magnetically, it retains the data even when the power is removed from the computer. A hard drive can only store a certain number of binary digits, and once the limit's been reached, some files must be deleted before new documents can be saved. And then I've got my conclusion, a binary revolution, with computers all around us such as smartphones, smart TVs, tablets, laptops and PCs, binary information has become a vital part of the information age. So that's just a nice conclusion that looks forward as a general picture. Okay, so there's my example of an explanation text. And it basically tells them what's going to happen from start to finish, from clicking save to it being on their hard drive. So what you're going to do today is you're going to do a plan using a boxed up sheet. So similar to what we've done before, we're going to fill in the boxes with notes. You can use pictures if you found that helpful. You can use bullet points, but we're going to get all the information that we want to include down and included on our page. So here's one that I've started for you, a bit of an example. And you can see I've used the boxes to organize my ideas into groups. So I've essentially got three sort of paragraphs here: saving the file, converting the file, and storing the file. And those are the three paragraphs that you see in my Waggle example. And in each one, I've got bullet points of the things I want to talk about. So the things that I want to make sentences of when I come to write up my final piece. Now, you might think, oh, do you know what? We learned a little bit about binary in the last few weeks. So I could include a little bit about how binary works. I could talk about a byte. I could talk about the value of byte. You could talk about how letters are stored because you know how to do that. So there's lots of information that you could include that I haven't included in my Waggle because you've learned that now. Okay, but this is about you getting the information down ready for next week. So next week when we write this, you want all your information ready to go and you're concentrating on just doing your best writing. Okay, so today, bronze, write your key vocab in. Know what vocab you want to use, know where you want to use it. Silver, organize the information into the right sections. So make sure that your sections are clear, that you know when you're going to talk about what. Gold, include your learning. So talk about your understanding of binary. Talk about binary column values. Talk about how you convert into a number, how you convert into a letter. And the challenge is to explain how text and numbers can be stored by the same binary digits. Okay, we've got some vocab here of binary, file, hard drive, digit, byte. These are words that you're going to want to include. Okay, they're going to be key to your explanation. Right, so today we're going to plan. Next week we're going to put this into a hot write. So we're going to do a really good explanation text because we'll have planned it really well. Best of luck.